Hi everyone, welcome to this video. Today we are going to discuss how we can perform a moderation analysis using SPSS and more specifically using process for SPSS. So process is one of the requisites to run the same things as what I will do in this video. So you first need to install process to do that. Okay, so here we have a data set where we want to describe the influence of a new learning method, right? So that's this variable here. So here we have an old method and here a new method that was implemented. So we have individuals taking either one or the other, so two groups. So we want to see the influence of this on the levels of performance at a task, and the levels of performance are recorded one day after. What the researchers think, though, is that the new method is actually only going to be useful for individuals that have a high cognitive flexibility. In other terms, their hypothesis is that cognitive flexibility moderates the effect of the learning method on performance. Alright, so let's see how we can check that. Let's click on Analyze, Regression, Process. I'm going to reset that. Okay, so this is what you should have if you just reset it. So here we have our three variables, and the first thing we are going to do is not change anything with these variables, but change our model number. Here we have a mediation model, that's model number 4. And by the way, you can see all the different models on a PDF that is on the process website. But here I'm going to tell you we are going to use model 1, which is the model that is used for moderation analysis. So we have to choose first model number 1. Okay, the next thing we're going to do is here select our DV. So our DV is obviously performance. Our IV is the learning method. But we think that the effect of the learning method on performance is different at different levels of cognitive flexibility. So cognitive flexibility is actually my M variable, my moderator variable. Let's now click on the options. There is one thing that we need to do, so let's keep that checked here. But we want to generate data for plotting, right? Notably, what we will want to have is a simple slopes graph. So process is not going to do that entirely for us because it cannot, but it's going to facilitate that a lot. So let's click here on generate data for plotting. Let's now click on continue. And in conditioning, we may want to check that here we have this pick-a-point approach, which basically will help us see the effect of the learning method on performance at 3 different levels of cognitive flexibility. And that's why it's called a pick-a-point approach. It's not going to tell us about every level of cognitive flexibility because it is an interval variable, right? So there can be a lot of values, but it's going to tell us what happens for individuals with a low cognitive flexibility, right? The mean minus 1 standard deviation for individuals with an average cognitive flexibility, and for individuals with a high, the mean plus 1 standard deviation, cognitive flexibility. So that is, of course, going to be very, very interesting for us to plot the results. So let's click on continue, and let's click on OK now. Okay, so you should see. Okay, so you should see a new output window showing up. Process takes a little time because it computes bootstrap confidence intervals, so it pre-samples. And so once this shows, we're ready to interpret. So what we have here is a summary of basically what we did and the sample size, but this we already knew. What we have that is new here is the model summary, and what we notably see is that we were able to explain 10% of the variance of the outcome, right? And once again, the outcome is performance. So we explained 10% of performance. We explained it, of course, with 2 predictors plus an interaction term because, as you know from the course, an interaction and moderation is the same thing. So here the interaction is the type of task, right? The type of learning method multiplied by cognitive flexibility. And that is the interaction term. Okay, so we have actually 3 predicting terms, even though we have only 2 predicting variables, right? We have the 2 main effects and we have the two-way interaction term. What we see is that cognitive flexibility does not have a significant effect on the outcome, but the type of task, the learning method, has a significant effect, and more importantly for us, the interaction term also has a significant effect. In other terms, we can directly here say that there is a significant interaction between the two, between cognitive flexibility and the learning method. Another way to say that is that we can already say from here that that cognitive flexibility moderates the effect of the learning method on the outcome. Now we get more information using process, because this, of course, we could do through other menus, other linear regression menus, or other generic linear model menus, such as the univariate menu in SPSS. But here we get more information. Notably, what we have is here the change in the R-square that is due to including the moderator. So basically, including the moderator changes a lot the R-square, because here we have an R-square of 0.099, right? And the interaction term is responsible for all of that, right, in this R-square. So that is actually a lot. And here, of course, we find the same p-value as the one we have here. So basically, we have a model without the interaction term that is compared here with a model with the interaction term. And it is actually significantly better. Okay, now how do we interpret this, now that we know that there is a significant moderation? So one way is, of course, to have a look at the coefficients here that are proposed by the pick-a-point approach. So the pick-a-point approach will basically have a look at 3 levels of cognitive flexibility and compute the conditional effect of the IV, which is the learning method, on the DV, which is performance, at these 3 different levels. Here at the mean of cognitive flexibility minus 1 standard deviation, the mean of cognitive flexibility, and the mean plus 1 standard deviation. In other terms, we could say at low cognitive flexibility, at average cognitive flexibility, and at high cognitive flexibility. So let's see what happens. Notably, we said there's supposed to be a stronger effect, a positive effect of the new learning method, which is coded as 1, right? So a stronger effect of this new learning method when individuals have a high cognitive flexibility. So here that is what we found, because here at low levels of cognitive flexibility, we see here that the new learning method has actually counterproductive effects, and these counterproductive effects are significant, right? So here we have a significant decrease in performance due to for individuals who have a low cognitive flexibility. Now, for individuals with an average cognitive flexibility, we have no effect on the level of performance, at least no significant effect on the level of performance. But for individuals with a high cognitive flexibility, then we have a significantly positive effect of the new learning method, right? So if we sum up this, what we find is that actually the new training compared with the old training has counterproductive effects for individuals with a low cognitive flexibility, no effect, at least no significant effect for individuals with an average cognitive flexibility, but it works much better for individuals with a high cognitive flexibility. So here, if we were to use the new training, we would essentially use it for individuals with a high cognitive flexibility. Let's see now how we can plot all of that to represent it graphically. So if I double click, so I'm going to double click here to activate this part as syntax. So you should see a different layout here. Right, I'm going to here select this data that has been generated for us to plot it. And so we're going to start here selecting from data and here end at task. Right, so this is, you may have recognized it. This is actually SPSS syntax. So I'm going to select that and just that, right? And I'm going to right click and click on copy. Next thing I'm going to do, I'm going to click on File, New, Syntax. I'm going to open a new syntax window. Okay, here it is. Let's now right click and paste the syntax that I have just copied. Now, next thing I'm going to do, if you have a new version of SPSS, you may run into this problem. At least I run into this problem using my SPSS 23. It may not happen for you, but anyway, I'm going to show you a little workaround on this. To do the simple slopes graph, you may run into a bug, basically, if you have here coded your categorical variable as zeros and ones. So here 0 is the old method and 1 is the new method. I'm going to change that for ones and twos. So I'm going here to say, right, so I'm before the point, right, before the dot here, I'm going to write 1, and here I'm going to replace by 2, 1, 2, 1, 2, right? Because, well, for some reason, when you do have a 0 for one of the categories, you may run into a bug in some versions of SPSS, right? So if you don't run into a bug, you don't need to change anything, but if you do, you may want to change that for ones and twos, for example. That's not going to change anything else. Let us now select all this syntax and click here on the green triangle to run this selection. Okay, so here we have data that is plotted to just give us our simple slopes graph. So this is not all the data, right? You have, if you count well, it's a lot less than 127, of course. Here we have essentially our pick-a-point approach, where we have where we will be able to see the different effects for the old task and for the new task. Okay, so let me here click on add fit line at subgroups. Okay, add fit line at subgroups. Okay, and you should see that you can keep it this way, but I'm going to remove the attached label to line so that it's clearer. Okay. Okay. So here it is, right? So here is a good way to plot the results. What we see here is that at low levels of cognitive flexibility, right, well, it is better if you have taken the old, right, the old learning method, right? You get higher performance scores than if you have taken the new. Now, if we have a look at average levels of cognitive flexibility, well, it's more or less the same, right? Whether you have taken the old or the new method. But now, when you have a look at high levels, right, mean plus 1 standard deviation of cognitive flexibility, what you find is actually the opposite as with low levels of cognitive flexibility, because what you find is that individuals who have taken a new learning method actually perform a lot better than individuals who have taken the old learning method. Right, so here we get some very interesting information using this moderation analysis, which we wouldn't have gotten if we had just looked at the overall effect of the learning method, right? If we hadn't dissociated between different levels of cognitive flexibility, what we may have found was that the new learning method did not change anything. Well, actually, it does. It is worse for some people. It doesn't change anything for some other people, but it changes for the better for other populations. So we get a higher level of information here using this moderating analysis. Okay, so thank you for watching this video on moderation.